I removed the top cover. I don't see no burn component, but let me show you what it's doing. So if we plug it to the power, yeah, no standby lights. The unit is completely dead. So right there in this socket right here, we have number one is a standby, 10 volt. Number two is a standby ground. Then we have AC cut and amp RY, maybe a relay. Let's go to the DC. We have 0 volt over there, so we have no standby voltage. So let's explain it. Let's go to the diode mode and we unplug the power and we check that fuse. The fuse is right there. That's one over there. The fuse is good. Let's take it more apart. This is a main transformer for the other voltages. 30 or 40 volt, positive and negative, 12 volt, 5 volt. And there is a standby transformer is right here. So that's the transformer is giving the standby. Okay, let's take it more apart and we check it. Yeah, that's the standby circuit. That's a standby transformer. Yeah, sometime by just smelling the transformer, you can tell if the transformer is good or bad. Yeah, when the transformer is bad, it will smells like a burned plastic. So we have rectified diodes where they check this input fuse is good, and capacitors still looks okay. So there's not a lot of things in this board. All right, let's start checking the stuff here. This is the input of the transformer, and that's the output pin. The transformer is getting 110 volt from here and giving about like 7 volt. When that 7 volt is go to the rectify bridge, that 7 volt AC, when it's go to the rectify bridge, it will be around 10 volt DC. So let's see here. We should have some resistance in the input because the transformer, there is just a coil inside it, a wire. So like here, you can see this coil. And here we should have some numbers, shouldn't be open. So likely this transformer is bad. Yeah. I do have this transformer is a linear transformer. It's not the switching. Yeah, the linear transformer is a little bit bigger than the switching transformer and heavier. So this is a 7 volt power supply. Okay, let's show you what's this. Like in the inputs here, what we have. You can hear, that's the input. Same as this input, to see the difference. This is open. That's the 110 input. Here is 110 input. And of course the output is good. So I'm going to use this transformer and we see. Right, so this is the input and that's the output. The output transformer wires is a little bit thicker than the input. Not this one, but the wire inside the transformer. Right. So that's the come from the fuse, that's the input, and that's one is the output. All right, you can see here is the 10 volt. Yep, we have 10.5. And I'm gonna put a hot glue around it. Put the device together and let's test it. just the minimum screws to hold the board and everything together. And they plug it. Nothing. Oh. Oh, this one is unplugged. Let me plug this one back. I plug it again. Oh, I see a smoke. Yeah, I see the smoke coming. I see the smoke coming. All right, I'm gonna unplug this one. And I'm gonna inject 10 volt over there and see what is the smoke is. So I don't want the transformer to be burned. And something is going on here. That's what caused the original transformer to get burned. All right, let's get to the power supply set up at 10 volt. And let's inject some voltage. So I'm going to inject the voltage to the standby line, 10 volt. You can see it's taking about 3 amp, and the voltage is dropping. It means there is a short somewhere. Yeah, sometimes yeah, you can see. Oh yeah. Yep, there is something is taking that load. A couple diodes, some capacitors, could be something over there. So let's put this alcohol. It's going to help us check which the component that's getting shorted, and I'm going to inject here in the standby pin number 1. Oh, you see this diode? And I think this, yeah, maybe that's that. The diode and capacitor is connecting. Yeah, they are connecting in the same line as this capacitor, and this capacitor is putting a load on this diode. Well, could be a bad diode as well. So we check the diode. So we have 0.1. That's not short. If we flip, we have open. So this diode is good. Basically, the problem, I don't think it's the diode. It could be this capacitor. .00, yeah, that capacitor is bad. Now let's remove that capacitor. Yep. Usually the shorted capacitor is easy to remove it because was a lot was overheated before and easy to crack open. So let's see if it still have the short. The short is gone, 2.8. All right, let's plug the, okay. Yep, I do have the standby. I did hear the relay. You can see the orange light. Here is the green light. And yeah, the screen, you can see its speaker are off. and there is a protector. Could be something else going on with it. Yeah. Yep. The device go to the protector mode and go off. Yeah, could be something else wrong with this one. So I already replaced the transformer. We remove that shirt. Yeah, after we fix the standby problem by replacing the standby transformer and removing the short capacitor right there that was causing the transformer to blow. Now we are facing the protect mode. Like the device try to turn on and it goes to the protect mode. You can see the standby light now is good. Here is the green. You can see the video, the speaker is off. Then protect. Yeah, most of the time this protect mode is from the shorted output transistor. Yeah, there is some cases because like open resistors or so there is two ways to check the transistors. You can test the transistors in the diode mode between the three pins, see where is the short or where is the open transistor. There is another way, more easy, is to test the voltage and the output resistors. This one's here, and we see which one it has like obvious reading voltage. So we put this one on the ground, and we are gonna measuring in the middle pin of this resistor. So you can see 0.1 volt. I'm gonna press the power button before the device go back to the standby mode. We are gonna have some voltage. You can see go almost 2 volt, then keep going up and down. By the maximum it was about like 2 volts something. So I can turn it off and go to the next one. Then I watch the voltage reading 2.6, then it keep going up and down, no more than that. Then the device is gonna go to the protect mode, so it's give you about like 3 seconds to test this the voltage in these resistors. Alright, let's give it some light like that. So we are on the third one. Each of these resistor is controlling one speaker. This is a 7-channel receiver. So right here, and we press the power button, 52 volt. That's not normal. Yeah, that's not normal. So we go next. So just 0.2 volt, but this one, look, 52 volt. Here, device is off. Yep, this one is just 0.2 volt. We go next. One point something. Alright, next. Yeah, except this one here, 52 volt. Other ones, they have very low reading. Yeah. So why the voltage is rising in that resistor? Because one of these transistors are shorted. Besides they are carrying, they are just passing the whole voltage. I'm gonna remove this board and to reach the bottom board. So in these two transistors that's close to the resistor, we had a higher reading. Just we check if there is any short in them. And we can compare these two here, compare them with these two, because each two transistor is powering one speaker. So this one is open. Oh, this one is short. Then 0.5, 1.3, 0.9, 2.3, 0.3 where we had the short. And the other one, 0.5, 0.5, 0.5. So even this transistor, the one that's not tested short, it has a different reading. So there is a small resistors around this area, and we need to check them too, because sometimes they may be open or okay, so this one is 2.6, and there is one similar to it next channel, 2.6. 100 ohm, 120 ohm. So there is a difference. 20 ohm, there is a difference. And here, mega ohm, and that's brown, black, brown. So 1 0 and another 0 should be 100 ohm. And this one here, 100 ohm. So beside we have 100 ohm, we have mega ohm in that resistor. So that's like a open. Alright, let's take the board, remove that resistor, we test them out, and we see if we have a replacement transistor, then we go from there. Yeah, in this transistor there is one NPN and the other one is PNP, so be sure we don't flip them. Just look at these ones, see who's the first, like this side is NPN, you're gonna put this side NPN. So this is the two transistors. One five. Yeah, 0.5 here, but we have nothing here. 0.4, 0.4, 0 ohm here. So this transistor is completely shorted. This one, not sure about it. Yeah, this transistor is bad as well. So it tested as just one diode. So one side of the transistor is bad. So it's not shorted, but is the one side tested open. Alright, and we need to take this resistor and this one. This one and this one we take. So one resistor it tests like 120 ohm, but it's supposed to be 100 ohm. Yep, this one is open. You can see it's a 7 mega ohm. And this one 120 ohm, supposed to be 100 ohm. So we need these two resistors and these two transistors. So I find these two transistors is close to these ones. Yeah, it's a different part number, but they match in the specs, like kind of same voltage, same amps. And this is the two resistors, 100 ohm. That is 100 ohm. Here is 100 ohm. So that one's good. And let me check these ones to be sure there is no short in them. Yeah, there is no short. So this one here, the B1560, is going to be the replacement of this one, MP1620. It's kind of the same, the setup of the transistors and these resistors. Same, you can see these arrows and this resistor, same base collector emitter. And this MN2488. See the resistor is down here, and we have the transistor facing to the emitter. Here transistor facing to the emitter, resistor here, base collector, and here base collector emitter. Yeah, the specs is very close to each other. Alright, let's check the specs just for one of them. Alright, you can see here minus 160 volt, and we have negative 10 amp. The base each will have 1 amp. Okay, let's go to the let's go to this one, same thing. here 160 volt, and my negative 160 volt, negative 10 amp, and the base, its max is negative 1 amp. So kind of the same, so it all works. All right, so this one is the replacement of this one, and this one replacement for that. 480H is the first one, so we have to put down, and we have to use this one with it. Let's put the resistor as well. It's gonna be a little bit hard because the resistors is the one I do have, it doesn't have a long legs. Alright, let's put it together and we test it. Hopefully it works. So we just put it half together. It's plugged in and the green light is on. Yep, I hear the relay of the speakers. So the system check the board for any overload or short. Then everything is okay. That's why we hear the relay of the speakers. So yeah, the device is fixed. I'm gonna put the speakers and then we test the sound. Alright, I already put the device together, so let's go to the, I select the radio. Oh, we hear the static. Yep, I hear the sound. So let's go to the Bluetooth. Okay, let me connect it to my phone. It's connected to the Bluetooth. Yep, it's connected to the Bluetooth. But this is the best one that is giving me a bit reading. So, and the problem that I found is in these two capacitors. C4. I can't see the name of it.
Wouldn't it be great if you could read and manage your business?
Alright, the device is fixed. That's all for this video, and see you again.